Hello everyone and welcome. I am Beth Mashesky, Senior Scientific Specialist at the Illinois Sustainable Technology Center, which is part of the Prairie Research Institute at the University of Illinois. A few housekeeping items before we get started. You can download some of the slides in the handout section of the GoToWebinar toolbar. Today's webinar is being recorded. The recording and slides will be available for viewing online in about a week. I'll be sending an email out to everyone who registered for the webinar once those are available. Everyone will remain muted for the entire webinar. There will be a significant portion of time for questions at the end of the webinar. You can type in your questions through the GoToWebinar toolbar, and I'll be reading those to the panelists. Please indicate which panelist you would like to answer your question when typing in your question if you'd like a specific panelist to answer. So with that, I'm very pleased to introduce my co-host, Jennifer Martin. Jennifer is an Environmental Program Development Specialist at the Illinois Sustainable Technology Center. She identifies and tracks emerging issues and research needs related to energy, waste, public health, and the environment. Through her work, she collaborates across commercial, public, and private sectors to expand ISTC's efforts to solve important environmental issues. Jennifer leads the Solar Photovoltaic End-of-Life Initiative at ISTC, and will tell you a little bit more about today's webinar and the panelists.
Thank you, Beth. So we'll start off our discussion today with a little background on why we're hosting this webinar. Solar power is the fastest growing energy source in the US right now, and at the end of 2019, over 76 gigawatts of solar has been installed across the country. The International Renewable Energy Agency projects a substantial increase in modules reaching their end of life starting this decade, with forecast of 60 to 78 million cumulative tons of modules entering the waste streams globally by 2050. US governments and states are now beginning to see the overall value in end-of-life PV requirements for circular economy. Today's seminar will include a panel discussion on barriers, policies, and opportunities for end-of-life solar modules in the US. Our panelists today include Amanda Cotton and John Glickson from the Minnesota Pollution Control Agency. Amanda's work at the agency includes 12 years of working on toxicity reduction, pollution prevention, and product stewardship initiatives. John has worked for the agency around 30 years, where he focuses on pollution prevention, developing policies and programs to identify and use a safer alternative for toxic substances. And he also is establishing collection and management infrastructures for households and businesses' toxic products. Our next presentation will be from Nancy Gills. Nancy is the CEO of the Green Electronics Council, or GEC, a mission-driven nonprofit that seeks to achieve a world of only sustainable information and communications technologies. GEC manages the Electronic Product Environmental Assessment Tool, or EPEAT, the leading global ecolab for electronic products. Before joining GEC, Nancy served as the global lead for resilient and responsible supply chains at Ernst & Young. Prior to that, she served as the director of the Federal Supply Chain Office at the US General Service Administration. Our last presentation will be from Dr. Garvin Heath. Garvin is a senior scientist and leader of sustainability analysis at the National Renewable Energy Laboratory. For the last 8 years, he has led the International Energy Agency's Photovoltaic Power Systems Task 12 on sustainability, where the US has gained valuable insights and lessons from countries with more experience in recycling and the circular economy of PV modules. He led development of a PV recycling technology R&D roadmap for the US Department of Energy, and has helped to develop a new voluntary sustainability leadership standard for PV module manufacturing, which includes end-of-life management. Garvin has been advising several US states considering voluntary and regulatory responses to PV end-of-life management challenges. So with that, I will hand the mic over to Amanda and John.
Thank you. And can you see the PowerPoint?
Yes, we can.
All right, so I'm going to put it in.
You're sharing your, yeah, there you go.
All right. All right, thank you for that. So yes, my name is Amanda Cotton. I'm the Electronic Waste Coordinator for Minnesota's e-waste statute. And while doing that, I've received questions probably pushing 2 years ago now about end-of-life management for solar panels. So looked initially into the rules on those. How does Minnesota currently handle them regarding RCRA? And then started a stakeholder process with John Gilkison to do research and discuss how to manage them for recycling. So we started out by wanted to create a goal, and we worked with others, initially with MNSEA, the Minnesota Solar Energy Industry Association and Commerce, and then it's grown to working with others since then. And we have this statement to develop and implement PV panel end-of-life management policy and programs that conserve resources, protect health, promote renewable energy, and support PV panel recycling infrastructure and technology. At the same time, we want to keep in mind Minnesota policies and statute for waste streams in general. So we have a waste management system goals, a hierarchy with reduction, reuse, recycling, materials recovery, and lastly, disposal. There's hazardous waste minimization. We need to think about the solar panels in the first place, what's going into them. The 2030 recycling and diversion goals for metro and non-metro counties in Minnesota. So trying to divert, goals to divert from the landfill. So I'm not going to go through each bullet, but this just shows what we've done over the past year. And we started out initially with a white paper John and I put together, and then those that were part of the group to begin with, and at any time now, really, you can give comments on that white paper just to try and get people at the same kind of level to start with. We had an initial survey, asked questions about a landfill ban. What about reuse? Methods for end of life. What about a timeline to get something in? We've had speakers that represent manufacturers, recyclers, SEIA, the national SEIA, Solar Energy Industry Association, higher education, other states such as Illinois, North Carolina, representatives from product stewardship programs, EPEAT, we'll get to hear about today. We had a survey most recently. We came up with, John and I, 4 potential models, and John will talk about that later. So in general, we've discussed why talk about this now, what are the current end-of-life rules for Minnesota, summary of US and EU policy, recyclers in the United States right now, cost of recycling, various solar panels that are out there, their potential toxicity, life cycle analysis, etc. So a focus for today, we want to talk about challenges and opportunities during this process. You're thinking about potential policy, and a couple challenges just beside policy that we've learned about through this process. Transportation. So there's just a small amount of panels, non-working panels per installer. So the cost to ship those, if he doesn't even fill a full truck, that can be tough to figure out. Recyclers, you could see it as an opportunity because we do have some in the Midwest, so we're fortunate to have that. But a couple challenges there is, they'll be running their line for e-waste, they'll have to stop that line, run solar panels when they have enough, stop that, clean up, and then start with e-waste again. And then just the challenge of getting the most out of the solar panels with what we do have for infrastructure for e-waste right now. And I think Garvin will be talking more about that today. The cost of recycling, You have, it's cheaper to, or it costs more to recycle than to have a panel go into a solid waste landfill if it's deemed non-hazardous. So that can be a decision at the end that folks might choose to, if it's tested and it's not hazardous, to do that cheaper route. Then education and awareness. So you have that, doing that with suppliers, installers, local government regarding PV panel recycling options and opportunities. So getting that information out to folks. And then at the same time, education and awareness for John and myself on the solar industry. So learning from those folks. Narrowing down to one end of life option. John will talk about this in some slides ahead, but you know, we have various options out there, and you'll see that people liked or didn't like all the options. There wasn't one that is standing out, you know, that everyone agrees on. And so that will be a challenge to figuring something out. And then costs, finally, I mean, just put it out there. This is a challenge. Who's going to pay for this? And while looking at that, you want to research the costs. What are the life cycle costs? What does it cost to install? What does it cost while it's working? Then decommissioning at the end. But then what are the revenues that are coming in during that time? So looking at that information or trying to gather that. And so far, our work indicates that recycling may represent about 5% of system installation costs, about the same as one cycle of inverter replacement during the project life. At the same time, you want to research life cycle assessment, looking at the carbon footprint of resources, energy that go into panels. So this information is out there, is just gathering that and educating people. One statement that comes up is that salvage value at the end of life will pay for decommissioning. And, you know, we want to caution that. We don't know if it will be sufficient enough to fund environmentally appropriate decommissioning or recycling. So we must plan ahead and set aside funds. And then if you did get salvage money at the end, all the better. So just challenges there to coming up with how to manage this when you have this different thoughts out there. But I will end with the cost statement here that, so as we've worked with the industry on this issue, people have shared their concerns about costs, since it is a highly competitive field with thin margins. The cost of recycling typically has not been well known or factored in. So people want to make sure that costs are reasonable, predictable, and will fall evenly or equitably on all players, so no one ends up with a particular advantage or disadvantage. So definitely challenges there. Opportunities, we've been able to do the stakeholder process. It's bringing everyone together. Anyone can join on our e-waste list, or excuse me, the email list, and give a chance to be heard and educated on potential options. We've been able to work commerce, PUC, admin to bring in recycling. They may not have been as focused on otherwise. John will talk about the Minnesota Solar and Wind Decommissioning Working Group. They have a report and recommendations. We were able to give comments during those comment periods. And then we have a state solar RFP and master contract. We were able to work with admin staff and talk about recycling with that. Other opportunities, work with manufacturer based right in Minnesota. Let's talk about toxicity of panels and the testing of panels and those results. Work with local governments so they have more information to make decisions. Working with MNSEA to have a connection to the solar industry. And then meeting with Representative Scott, I'll talk about next, to learn about her thoughts on a product stewardship bill that was introduced to Minnesota, and let her know that the industry is talking. So just want to make everyone aware, Representative Scott in 2018 and then earlier this year had a PV panel stewardship bill. It wasn't heard due to COVID. It models the Minnesota paint stewardship law with some e-waste provisions. So those in Minnesota, you go to buy a gallon of paint and you'll have a fee on there, like an advanced recycling fee, like 90 cents or so, and then it's free recycling at the end. So Representative Scott was on the committees that heard the paint and e-waste bills and concerned that we need to stay ahead of the curve on PV panel and of life management issues. So she put that out there. Got to meet with her, and she's open to hearing ideas from the stakeholder group. All right, and I am going to pass it on to John.
All right, thank you very much, Amanda. So one of the things that we've been looking at in terms of both current volume and the future is what are the numbers of panels that might be coming out of service. And we don't really have very good on-the-ground numbers right now for what might be coming out of service or what is forecast to be installed. So we looked at some global and U.S. estimates, and this table shows sort of a distillation from some global estimates and an International Renewable Energy Agency publication, and then there was a student working under an IEEE project who put together a paper that you can look at that brought the IRENA numbers down to the state level or down to the U.S. level, and then we took 1.7% of the U.S., which is what Minnesota represents on a population basis. And we've also done some number crunching, and we're just about exactly average in terms of panel installations. We have about 1.7% of the panels in the U.S. So the IRENA estimates have both a regular retirement model and an early retirement model based on certain percentages failing along the way for various reasons. So you can see these panel estimates here, and what's interesting, for example, is that between 2016 and 2020 on the regular option, the volume doubles. Then between 2030 and 2040, it's an order of magnitude. And on the early retirement scenario, we get some pretty substantial increases, 10 to 12 times between 2020 and 2030, and then order of magnitude 2030 to 2050. And of course, this is just snapshots of those years, so your cumulative in the intervening is also following these curves. So we have a substantial problem out there that we need to address. And I do want to say that our focus is not on the specifics of life cycle assessment and recycling technology issues for our process and participants. We're tracking what's going on. You'll hear more from Garvin about some of these later. Our focus is developing policy and financing options so that we can have the very high recovery rates that we feel are necessary to make recycling both very cost effective and be able to recover at a high percentage of the resources in those panels and put them back into new panels and other high value products that we can make in the U.S. and retain the value of the materials. And that volume is also necessary to make reuse and refurbishment possible, we believe. But that's an area that's not very well understood right now, and we haven't addressed it too much in our process except to identify it as a priority. So next slide, Amanda. So the most recent meeting that we had of our stakeholder group was to get some initial reaction to 4 models for end-of-life management in Minnesota, and there's more extensive description of these in later slides in the presentation you can download. But essentially, with the 4 models are one is our Department of Commerce and Public Utility Commission have decommissioning requirements for certain utility scale or certain wind and solar facilities. So they are currently working on guidelines and requirements to refine those decommissioning plan requirements for the facilities. But our proposal would be to take that permittee responsibility model and extend it to all solar facilities. Currently, it applies to solar facilities of 50 megawatts and greater. And essentially, that is a requirement to have an initial plan for the initial permit application, updated every 5 years, updated with a permit amendment or change of ownership, and then establish financing that starts no later than year 10, and the decommissioning is fully financed at the end of the permit term or end of project life. The second model that we have put out there for discussion is a product stewardship model. And in that case, there would be a fee assessed on the sale of the panels, potentially internalized by the manufacturers, potentially paid by the purchasers or permittees. And then that would fund end-of-life management for all panels removed from service. A couple advantages of that are to provide some incentives for design for recycling and design for reuse of recovered materials from panels. Also, another advantage is that that funds the management of orphan panels. For example, if you have a company go out of business or you have premature failure of panels, as has happened with some products out there, then that's covered. That's not left as a liability with the permittee or the owner of the installation. The third one we looked at was to have a ratepayer funded model and a statewide end-of-life program. And so that ratepayer funded model, everybody in the state would pay to fund a program that would handle end-of-life panels and other equipment. And that would probably be based on a consumption of electricity. And the fourth model we have is a permittee funded model where the permittees of the solar installations would pay into a fund for a statewide management program, and that could be structured financially with different models. It could be based on the number of panels, it could be based on generation, it could be based on overall capacity. So we haven't gotten into those details yet, but some other things that we covered in our June 11 stakeholder meeting were updates on other states and Europe. We are looking at some local government challenges that some of you may have in your state. For example, all solar installations under 50 megawatts in Minnesota are permitted at the county level or potentially even at a more local unit of government. And so we have 87 counties out there trying to do the right thing with a range of expertise and knowledge on these issues. Trying to coordinate with each other and be consistent, and often hearing some, I guess might say, fantastic estimates of end-of-life management value or project life or revenue that's going to be realized by the local government as part of the process. There's a lot of challenges at that level. Also, we gave an update on the decommissioning guidance, and we talked about some survey results on these models. So next slide, Amanda.
Oops, I'm sorry.
Yep. So just to give an idea of who was involved in our last session and who gave some feedback on the models, you can look at this later with the downloaded copy, but essentially 3/4 of our participants are evenly split between the solar industry and all levels of government. And then the remainder of our participants are academic, consultant, utility, and members of the general public. Next slide. So here are the 4 options. We did a little mini survey, and unfortunately this is incomplete. So just take this as a snapshot or illustrative version of how you could gauge some support or opposition on these. So option 1 is the Commerce PUC model. Option 2 is product stewardship. Option 3 is ratepayer funded, and option 4 is permittee funded. And you can see that there's pretty even support for all of them as a first or second choice, but then people have very strong opinions about what ranks lower in the hierarchy. So how can we interpret this? So what we did to try to make sense of this was we gave points for top choices and points or points for each model, and then we had points against each model, and then we did a total 4 points minus the total against points. And what we came up with was first choice was a tie between option 2, the product stewardship, and option 4, the permittee-funded statewide program, and both of those had 3 points. The third choice was the ratepayer-funded statewide program with 1 point. And the fourth choice was the Commerce PUC permittee responsibility individual management plan option, which came in with -7. We were kind of surprised about that because this is an existing program, but we haven't had time to talk with people about why this might have been ranked last. Possibly because it has more rigorous requirements with the planning and financial assurance throughout the whole process versus just paying a fee to a statewide program and letting somebody else worry about all the details. So next slide. So just a little more detail on what the current decommissioning requirements and framework are in Minnesota. All of the solar and wind facilities that are permitted have these requirements. They currently cover solar facilities over 50 megawatts and wind over 5 megawatts. Commerce has asked for permitting authority for solar down to 5 megawatts, but that authority has not been granted by the legislature. There are, excuse me, laws and rules governing these decommissioning plans, but they're very they're vague. There's not a lot of guidance in there except that it has to be done. So the Department of Commerce convened a working group a couple of years ago that issued a very good report, and they had a lot of recommendations for the level of detail that needed to be in here, the timing for the initial and updated plans, and then they reviewed a number of financing mechanisms, generally agreeing that you don't need to finance up front, but you need to start no later than halfway through the project and be fully funded at end of life. Commerce had that working group report out for comments. Last fall, they developed another set of more detailed guidance principles that was out for comment again this spring. And to reiterate one thing that Amanda mentioned, they're probably not going to allow estimates of scrap value to be part of the end-of-life financing plan because there's so much volatility and unpredictability in that. That would be considered a bonus for the owners at the end of life. Let's see, I think that covers that. Next slide, please. So to go into a little bit into the state solar master contract, we were able to put some recycling provisions into the state agency contract this year. We have requirements for the recycling of PV panels and inverters provided under the contract that are replaced under warranty, cease to function for any reason, or are covered under an operations and maintenance agreement. That last clause should, with the other two, cover everything because there is a requirement for the contractor or a successor to have an operations and maintenance agreement for these installations in state agency facilities. We have a requirement for the contractors to annually report their recycling to our agency, and we have a requirement for pollinator-friendly plantings meeting state guidelines for all ground mount installations. And agencies can add additional requirements for their site-specific solicitations. And so this contract was just published on the state procurement webpage at the end of September. It's now in effect with 6 vendors. And we can share the specific language of those clauses with anybody who's interested. Also, we're doing a study on putting solar on closed landfills. This has been an issue that has had a lot of controversy in the past, but people have finally agreed that it needs to be researched and move forward if possible. Currently, the Bar Engineering is a consultant on this study. Minnesota Environmental Quality Board is the lead agency. They found that there's potentially more legal than technical challenges, and specifically, the state has a closed landfill program and either owns or manages many of the closed landfills, and the bonding that's been used to run that program has a lot of restrictions on income from other projects or what can be done with the facilities once the bonds have been used to close them and monitor them and hold them, sort of hold them in trust by the state. So there's going to be a discussion of the draft report in mid-November. You can get information on that on these sites probably after November 6th, and then the final report's due to the legislature on December 1st. If any of these move forward, they probably can use the state solar master contract that we were just discussing. And I think that's it. And happy to take questions at the end. I think we're taking all questions at the end on the models and any of the other issues we're working on. Thank you very much.
Great, thank you, Amanda and John.
Good morning. I think it's still morning everywhere where people are listening, probably. This is, I'm Garvin Heath. I work at the National Renewable Energy Lab. I was introduced before, and pleased to present on a paper that was published this summer that provides a research and development roadmap for crystalline silicon as an area of focus. Technology of focus, PV recycling technology development. I'm going to touch on some other things and include actually at the end mention of some other publications that you all might be interested in, including foreshadowing some forthcoming ones. Hopefully that will be out relatively soon. Come on, let's advance. Okay, hopefully this is going to work. All right, so I'm just going to start. Actually, John mentioned this projection that was done on a global basis, but also for individual countries as well as collective countries and regions, published in 2016. That the International Energy Agency group that I lead, IEA PVPS or PV Power Systems Task 12 PV Sustainability, in collaboration with IRENA, International Renewable Energy Agency. And it, I think, remains still the, I guess, the leading estimate of projection of end-of-life PV modules. Not to say that this couldn't be improved, which it can, and in addition, of course, updated. But nevertheless, it shows that the United States has the second largest expected by 2050 volume of end-of-life PV modules, second half, but second compared to China. The inset figure shows a projection in three different sort of ways. The top one is the projected mass of PV in service, so that's all the PV that's actually installed. And then, of course, after 30 years, roughly speaking, with some early end-of-life considerations in this projection, you reach then the end-of-life volume, so that which reaches that 30-year mark, 30 years being the typical warranty period for new PV modules. And then the green line is the annual PV waste, and that's also, of course, growing. And it's a logarithmic scale, as you should note on the left. And to put this in perspective, the category that photovoltaics fits in is electronic waste, e-waste. which set a record in 2014. Probably this could be updated, but was about 42 million metric tons, and annual PV waste in that year was about 1,000 times less. So, you know, a drop in that bucket, as it were. But by 2050, PV panel or PV modules end of life could exceed 10% of that record global e-waste level, and 10% for a single product, and the growth over that time period is significant. And so we want to try to get ahead of this issue, is what the IEA group that I lead and other researchers feel. Governments are starting to recognize the future challenge, and of course I'm in talking here in the context of Illinois, recognizing that and having dialogue for more than a year on this. I've just spoken after Minnesota, who has also recognized this as an issue. Other states are starting to act. There are 2 laws for study commissions in North Carolina and New Jersey that are going, but Washington State was the first to enact a recycling mandate in the US. They actually delayed the implementation date of that by 2 years, but nevertheless, that's coming up. This was following, of course, Europe, which has the first and most comprehensive recycling mandate in the world. But other countries are starting to pay attention too. So I have listed here on the map, Korea, Japan, Australia, India, all of which in different ways have been exploring the issue or even starting to develop mandates. There are, we shouldn't forget that there are many circular economy pathways for PV. Circular economy is perhaps a word you all have been hearing recently. It talks about trying to make maximal use of materials and, of course, not lock them away in landfills at end of life. So this is a famous, what they call butterfly diagram. There's a whole left side of the diagram, which is the biological side, but the relevant for us here for PV modules is the right side. And the last loop, the outermost loop, is recycling. The innermost loops are actually more favorable. So if we can maintain and therefore extend the lifetime of products, if we can reuse, so provide a second life for them. Refurbishing, remanufacturing is probably not too likely for PV modules. The costs are just too low for new modules to want to really go in depth and refurbish or remanufacture them. But then there's recycling. Now, all those inner loops are important, and certainly maintenance is something that's being done now. Secondary markets are relatively small due to some issues around codes and standards and just lack of awareness, and perhaps also some other things like lack of warranties and such. So there are numerous business model, economic, and regulatory challenges to some of these other loops. But you know, all modules do reach end of life at some time, and even after they're maintained, even after they're given to a secondary market, at some point they're going to reach end of life, and that's where the last loop of recycling really comes in. So why do we want to recycle modules? Well, this is built on the projection I showed earlier, which was out to 2050, but here, just in 2030 to be illustrative, this is the cumulative technical potential being if we were to recover everything. Now, we wouldn't be able to do that. We're not going to be at 100% of recovering every one of these materials. But nevertheless, if we were, this is the sort of the stack of the materials that are in modules. So glass is by far the largest amount of weight within a module. After that is a combination of different polymers, actually. Then aluminum frames for crystalline silicon modules, of course, silicon, copper, other metals. That's where we're starting to get into, as you can probably read if you know the periodic table. These are some precious materials. These are also sometimes critical materials, and in some cases they're toxic materials. So those are really where a lot of the value lies, and also in the silver, which is in the very top of that chart, so the least. But but one challenge we have is that there's a dematerialization going on. That's a good trend for the demand for materials, but it also puts challenge for the recycling economics at end of life, because some of the most valuable materials are the ones that they are making less and less of that material in a module in order to try to reduce costs. So silver is a good example of that, but also silicon is another example. But nevertheless, there's a lot of value. So based on that technical potential and just focusing on the 2050 loop there, that's as the waste projection or the end of life module projection, up to 80 million metric tons globally. But if you apply just a standard value, and of course this value does fluctuate, but if you apply a standard value, that's about US $15 billion worth of raw materials globally, cumulatively by 2050. But that's a lot of money. And so there's for sure going to be some sort of industry and also employment opportunities that come from that. And if we were in a sort of perfectly circular world, which is not necessarily going to happen, or even the best choice, there could be higher order uses than returning just to PV. But if you did, that would be equivalent of the materials to produce 2 billion new panels, which is a lot, 630 gigawatts. There's going to be more solar deployed than that. It can't supply all the raw materials for new expected solar by 2050, but nevertheless, that's an important contribution. So what's the practice now for recycling? We did a survey, this international group that I lead and a collaborator, Karsten Wambach, did a survey, and we got 5 responses back from recyclers in Europe. And one of them was from a prototype system that was not operating commercially, but the first 4 were from existing recyclers that were accepting PV modules. 3 of them were glass recyclers, 1 of them was a metal recycler. They can all meet at the time what was the requirement under the WEEE regulations in Europe of mass fraction recovery. So 75% of the mass of a module had to be recovered. But that really misses almost all of the trace materials. And by and large, that's a similar situation as we have in the US. Now, there have been improvements to even the existing line recycling technologies, but there's still challenges for certain materials, the quality and the form factor of that's recovered and what value that presents, what markets that can go into. I should note here that cadmium telluride is a PV technology that has had dedicated PV recycling for years, for around a decade. First Solar is a US manufacturer and is the leading global manufacturer of cadmium telluride modules. So more or less, that situation as far as recycling and even the take-back that company has offered of their modules addresses that technology. For crystalline silicon, though, there's only one commercially at commercial scale and operating today crystalline silicon recycling facility that's dedicated just to PV modules in the world. That's in France, run by a company called Veolia. So crystalline silicon is at a different state of maturity than cadmium telluride. What we've found in reviewing the literature, and you can see there's another publication that we published in 2018 that looked at trends in PV module recycling technology development. We looked at it both from a perspective of kind of research articles, that's some of the summary here, but also patents, so representing private sector interest. And most of the studies, as well as patents, reflect a focus on bulk materials and not as much on specialty materials, those that are in the smaller size fraction for modules, but represent a lot of the value and also potential toxicity that we want to control. So AG being silver, copper, tin, lead in the B labeled frame to the right. And so it's also really in the combination of trying to get all of these materials recovered in the same process that we think there's a lot of potential. And that's something that we called high value PV recycling. So that's what we're going to focus on in the next slides, which come from a paper, as I mentioned, that was published this summer, where we have, I guess, 6 recommendations, and in the 7th section that focused on policy, logistics, and data needs. So the first 4 of these recommendations focused on silicon, and that's because we found a lot of value potential in silicon that's not yet realized. And then the next 2 were focused on other analyses and trends in the field, as well as the 7th, as I said, on policy, logistics, and data needs. So I'll go over in the slide each of these recommendations. So the first recommendation we had was to emphasize R&D on high-value silicon recovery. So why focus on silicon? We did a cost analysis based on 2, and then a combination, so a third recycling process, and the value potential range between, if you were to recover silicon at a maximum, a theoretical maximum revenue, where that silicon is actually recovered or upgraded to solar grade silicon. That's a grade of silicon that's I think they call it the purest man-made substance on Earth. Versus what it generally is recovered today, where it has some contamination in it, and it can only be sold as what's called metallurgical grade silicon, which is only 98% pure, not nearly as pure as solar grade silicon. That differential represents potential revenue on silicon, and that's a target then for trying to improve the economics of recycling. It also helps in terms of the environmental performance of the total life cycle of PV, because silicon, because it's the purest man-made substance on Earth, it has a lot of energy that went into making it that pure. And so if you can recover that silicon, then you can help to offset what is a large part of the embodied energy and embodied greenhouse gas emissions in a crystalline silicon module. So what we also, the second recommendation said was that to de-emphasize R&D on recycling processes designed to recover intact silicon wafers. This has been demonstrated at laboratory scale that you can do this, you can recover intact silicon wafers, but we think that there's a lot of sort of reason to caution wanting to put a lot of emphasis on research and development in this area. That's because we don't think it's very likely that very many cells or wafers are going to be able to be recovered at end of life that aren't cracked or in some way damaged through operation, actually through starting with installation and transportation, but also, of course, at end of life. And then the question becomes also, you're recovering old silicon wafers, are they going to meet today's requirements for new silicon wafers in that competition? And as many observers of the PV field know, there's been a steadily increasing cell efficiencies, cell lifetimes. That's actually largely because they've been able to continue to improve the purity, so reducing the impurity of the silicon that's coming into their manufacturing processes. There have actually been changes in cell form factor and size. So all of those suggest that old modules and their, when can recover an intact wafer, are not really going to meet today's requirements. Furthermore, silicon manufacturing processes are designed for polysilicon as inputs, and broken cell fragments may not be immediately usable. Focusing again on silicon and the recovery of silicon in high-value PV recycling systems, a third recommendation we made is to design silicon purification and crystal growth processes for recovered silicon to increase circularity. So recovered silicon is going to have different profile than virgin silicon. So this manufacturing process, which of course is being done at very, very large scale by some very large silicon manufacturers, silicon serving not just the PV market, but also of course semiconductors. This is going to require some research and be a challenge to optimize this, but we think it's potentially worthwhile doing so. Oh, come on, there we go. Okay, and so we'll need to investigate the characteristics of recovered silicon in order to do that, and to inform then its return to the silicon value chain. So there's lots of ways that impurities can get into silicon from the late stages of manufacturing processes, but of course, also during operation, and then in addition, during end-of-life recovery, so that impurities can be introduced, and those need to be characterized in order to understand how you can, and where in the supply chain process you can, return the silicon, recovered silicon that is, back into the value chain. So now moving away from the focus on silicon, we recommended that the community uses some what we call kind of anticipatory systems-based analytical tools to help to inform the benefits of different recycling systems and combination of different recycling steps. This is an analysis of in a particular recycling process, the stages of recycling and where the costs and the type of cost occur. And so you can see that in this particular process, almost all of the cost is just in one step. That then obviously becomes an opportunity for research and development to hone in on that step and try to reduce those costs. So that's what's called a techno-economic analysis. On the environmental side, you want to use, there's an approach that one can use called life cycle assessment, which also considers holistically across that whole now life cycle, not just manufacturing, but also operation phase and then end of life phase, so that you can optimize that. And you can do a life cycle assessment just on a recycling process in addition. So where are the environmental burdens coming from? Likely it's going to be where costs are, but not necessarily. The recycling, because recycling infrastructure is long-lived and it's capital intensive, we also know conversely that PV modules have changed in their design considerably over time. Therefore, we think that the recycling infrastructure for PV needs to try to consider as much as possible where the PV technology is now, and to then sort of track that industry about how designs are going to change in the future. The inset figure shows the reduction in silver consumption that was projected at the time in from 2013 forward, but has largely been followed, where that the silver is being dematerialized out of the modules in order to reduce costs, but that also, as I said, affects the value recovery, since silver is a highly valuable material that has been a target of recycling and has helped to make the economics of recycling better. So there's also policies, and of course, I'm giving this webinar in the context of Illinois and with colleagues in Minnesota who are considering policy options. But also there are logistics and data needs to consider. One large area of still some uncertainty is the waste classification for PV modules. Are they hazardous or non-hazardous? And it's not something that's very easy to answer. And in fact, there's an ASTM committee that's forming to try to develop, not to change EPA's TCLP, Toxicity Characterization Leaching Protocol test, but just how do you do sampling appropriately of PV modules to then send it to that test to determine whether a module is hazardous or not. There have been discussions about whether recycling facilities should be centralized or decentralized, should be small scale or large scale, and what are the benefits of each of those different approaches. The end of life projections that I showed in the beginning, I said that they could be improved, and some of the ways that they could be improved is to make them more granular. How about doing them at the state level in the US? I think that would benefit the recycling industry and also the policy community a lot. In addition, at the time for making that IEA IRENA projection, we did not consider several ways that modules could reach early end of life, such as through extreme weather and repowering. So deciding for economic reasons to change out modules earlier than otherwise they would be. And there's improved understanding about breakage and failure modes that can be incorporated into these projections. So I wanted to mention here in closing a few other publications on a couple slides here that you all can try to find if you're interested. This IEA group that I lead, we've published a series of three reports that are on different exposure routes or potential exposure routes in terms of the presentation of human health risk from these different routes. The first we focused on was PV exposed to fire and the fumes that can result from that. The second was focused on PV modules that are broken, but they're left in the field, in which case there's an avenue for water migration and then leaching of chemicals out of those modules onto the soil, into the water table, et cetera. And the third, perhaps most relevant here, especially in terms of end of life, is from module disposal. And by module disposal, and really the approach we took for all of these was to develop methods. But the methods for human health risk assessment, especially in a regulatory context, are meant to be health protective. So at every place along the way where you're making an assumption in your analytical, in your analysis, in your modeling, you make a health protective assumption. So in other words, a risk conservative assumption. And by doing so, you're developing what might be called a worst case, or at least a higher end case of potential risk, but at least you're being protective of human health in that approach. None of these potential exposure routes did we find when we focused on a single chemical, the highest prioritized chemical, but a single chemical for each of 2 or 3, depending on the scenario, module technology. So for instance, lead in crystalline silicon modules, cadmium in cadmium telluride modules. In all of these cases of fire, breakage, and module disposal in landfills, did we find that the risks presented or analyzed in these kind of worst case under these worst case assumptions, did they present risk above thresholds set by the US EPA and WHO for risk for these chemicals? So that's, I think, good news. PV is not presenting high risk to humans, especially in the module disposal context. It's not to say that we are advocating landfilling of modules. We are not. But it is saying that if modules do get landfilled, which is happening in the US right now, that we at least focused on the one highest prioritized chemical for each of those module technologies. We don't find that there's a significant over threshold risk to draw more attention and need for further study. Then there's a lot of other work that you could find on that IAEA website that I showed previously. I've drawn upon many of these reports in the slides that I've shown previously. So we did a life cycle assessment of current PV module recycling. I showed you the inventory and the survey that we did on a previous slide. Then we actually did an LCA on that. I showed you trends in PV module recycling technology development, both from the academic articles as well as patents. And then, of course, the R&D priorities article that was published. But we also have a lot of forthcoming work that maybe I can prelude. We've been looking at using behavioral science to try to understand the socio-technical dynamics of the circular economy for PV, and are putting together an article on that. In peer review is an article on principles for design for recycling for PV modules. Actually, also wind and wind turbine blades and batteries is in that article too. We've done some policy analysis, overviewing of US policies, and also some focus on recycling, and then some broader considerations about circular economy. That's also in peer review. And then we, on the IAEA PVPS side of things, we have a forthcoming report looking at module reuse and examining the business and environmental case for module reuse and limitations on that. And then looking broadly at PV sustainability standards and their effects in markets. So these are reports that within the next months ahead, you can find on either NREL's or PVPS Task 12 website. And yes, I want to thank my co-authors and funding from the Department of Energy for this work.
My name is Nancy Gillis. I'm the CEO of the Green Electronics Council. We're a nonprofit organization that focuses on creating a world of only sustainable technology. Next slide. In the interest of not taking unnecessary bandwidth, here you can see a picture of myself, and I'm not going to go ahead and project. Next slide, please. For those of you who may not know the Green Electronics Council, as I said, we are a nonprofit. We do embrace the use of technology when it works. It works very well and serves a lot of our individual and professional needs, but we refuse to accept all of the benefits of technology at the price of people or planet. Next slide, please. The way that the Green Electronics Council seeks to achieve this world of only sustainable technology is by supporting institutional purchasers. And as was referenced earlier, several of you who are participating today may already know one of our flagship programs, which is the eco-label EPEAT. EPEAT is a type 1 eco-label, which means that all product claims are third-party validated. And next slide, please. EPEAT has been focused on this prior week launching a new category that covers photovoltaic modules and inverters. That category was launched because of the Green Electronics Council's recognition of not only the growth of renewable energy, but the growth of solar technology as part of renewable energy adoption. And as already mentioned by the two prior speakers, that the growth of solar technology has meant also that we are facing end-of-life challenges with that technology. Next slide. Now, the Green Electronics Council, when I mentioned EPEAT as an eco-label, it is an eco-label that's been around for more than a decade. And so we have some experience on how to address technology products. So as you can see here, our prior categories that we've covered, such as computers and imaging equipment, intelligent televisions, mobile phones, and servers, what's been similar about those that's dissimilar for PV modules is the lifetime of those products. So there's nothing that really has the time duration of more than a decade than that a PV module has. So in launching this category and developing the criteria that underpin that category, there was a challenge in actually understanding how to address end of life when end of life is something that is so different than the technologies that EPEAT has historical understanding of how to address. Next slide. And so for EPEAT, we differ than most any other eco-label because we have both required and optional criteria. Required criteria are to make sure that when global purchasers, be they in the public or the private sector, when they rely on this eco-label, that they're actually getting credible, sustainable products. And that, of course, is what is applied to the newly launched photovoltaic module and inverter category as well. But we also include optional criteria because we're trying to signal and drive the market to a type of performance. Now, when products meet optional criteria, they move up to tiers in the EPEAT eco-label. So a product that meets more optional criteria than is the required is a silver product. The one that meets, in essence, what we consider the maximum or more than 75% of the optional criteria that are within the category are ones that are considered gold. And what we've been trying to do is, as we were formulating the criteria for this category, is think through what is the role of optional criteria to actually push the market in addressing some of the challenges we've already heard discussed just in this webinar on end of life. And that's actually been difficult. As you saw from the first presenter, one of the prior experiences that EPEAT has had for the other technology categories that we cover is the fact that there's a strong reliance on take-back and producer responsibility. But there's also a strong reliance for those other technologies on there being a viable recycling sector available, so that if one holds the producers responsible for taking back and then actually addressing through recycling, appropriate recycling technologies, to assume the responsibility of doing that, that there is a system of take back and recycling that they can tie into. And of course, if we've heard today, that's not necessarily the case. And in part, it's not necessarily the case because this is both a new technology that has had tremendous growth, right? Solar technology and PV modules. It's also a new technology in that lifetime of 10 to 15 years that most modules are expected to be functioning, that means that there is a significant ebb and flow that was expected for these products to actually hit the recycling stream. And as was again already mentioned, a concern about the capability, the economic viability of recycling entities to actually be prepared to credibly and appropriately recycle these technologies when there isn't, as are with some of the other technologies, a consistent supply. So these are some of the challenges that, as we were thinking through criteria development and particularly end of life, how to address. Next slide. So I mentioned that the EPEAT eco-label has launched this category, and we do have criteria. The criteria do not only focus on end of life. We are a life cycle eco-label, which means that the criteria actually address other sustainability impact areas as well. And here you see just an example of the specific photovoltaic and inverter criteria that we have bucketed into the sustainability impacts that we've heard are of considerable interest by purchasers globally. And of course, here focusing on both chemicals of concern, climate change, of course, climate change mitigation, corporate performance. So EPEAT doesn't just focus on the product itself, but also the performance, the sustainability performance of the provider of that product, and then sustainable use of resources. Next slide, please. As I mentioned, some of the criteria of EPEAT do focus on end of life, and some of those are challenging absent the system of take back and recycling capability that we see available for the other technologies. But for the criteria that are there, as manufacturers go through the process of going and submitting their products to EPEAT for consideration, we do, and I want to emphasize, especially any of the participants who are coming from Europe, that we do have third-party validation of EPEAT claims. And so when we have third-party validation, think about also what challenge that provides when you are considering what are some of the end-of-life requirements or criteria that EPEAT has within it. Challenge of third-party validation of those criteria. Next slide, please. And so for what we're happy to say is for our launch last week of our category, one of the manufacturers who at launch had products available in that category was First Solar. And I think one of the last slides that you saw Garvin talk about is the fact that the technology that First Solar has relied on has a dedicated recycling stream. So again, not surprisingly, that First Solar was the first major producer of PV modules who actually started to engage at midpoint of this year with our organization and with their external third-party validator, their certification firm, VDE, to confirm that they met criteria because they were in the position to meet the end of life criteria. Next slide, please. And so we're excited that, next slide, please, that First Solar products are available in the category. If you want to see that category, you can go to the EPEAT registry. That is the online site where all EPEAT registered products can be found. Again, these are products that have been validated, their claims validated by third-party certifiers. And you'll see the addition, for those of you who already know the EPEAT registry, of the photovoltaic modules and inverters category. Next slide, please. And so what I believe, I didn't quite see if Garvin's presentation had already gotten to it. What we're super excited about is the fact of having the EPEAT eco-label actually already be cited in guidance for purchasers of renewable energy. And by that, I mean the Renewable Energy Buyers Alliance, REBA, a report that I think actually is being formally released today, if my timing is correct, which is this more than a megawatt report, that it does highlight EPEAT and give guidance on how to utilize EPEAT when actually deciding upon sustainable photovoltaic modules and inverters, as part of a solar system procurement. So I believe that was my last slide. Thank you very much.
We did have one come in during John's presentation, and that one is why the early estimated panel requirement for 4 to 8 times higher than general. What are these numbers based on?
That's a very good question, and I can't answer it right on the presentation today. You would have to go back to the IRENA study where they talk about that in depth. There are a number of assumptions about breakage or failure at certain points in panel life. They assume a higher failure rate at initial installation, and a higher failure rate during the first 10 years. And it's just a matter of a couple percent failure rate, if I remember correctly. But it makes a huge difference over the lifetime versus the regular assumes just a fixed and very low percentage fail during the 25-year life of the panels. So it's in the IRENA study, the assumptions for the early and regular models that we cite in the slide.
What is the current state of the art on solar panel management in Europe? How are they handling this issue?
This is Garvin, and I presented on one of my slides, it's a couple years old, but a survey we did of recycling in Europe. And besides for cadmium telluride modules, the recycling that's being done in Europe is being done, it's for, the world's first dedicated. The Veolia facility is one that's in France, and it serves the French market. I don't believe they're taking modules from other countries, but I may be wrong on that. But suffice to say that most of the other countries have to have their own solution, and it's using existing recycling facilities.
So Garvin, isn't there a facility in Italy that's maybe it's an R&D facility, but is looking at high partitioning, high value recovery?
Yep, and you're right. It was only a research, so it was a pilot scale facility that was not able to operate because there weren't enough modules to make it economic to operate. So they mothballed it. But it's still a technology that's being researched.
I think that's the dilemma with all of this now but the volume is low right now. So having the volume of panels to make a dedicated recycling facility operational at a reasonable amount, plus the issue of recertifying panels for reuse. Refurbishment might just mean recertification. It doesn't necessarily have to mean that you're technically modifying a panel, but we don't have enough to do that yet either. So both of these are sort of pending issues that need to be addressed more as we generate more panels.
And this is Nancy from the Green Electronics Council. What I can say is one of the criteria that we focused on to address this is the recycling, especially in Europe, and they have an emphasis on this, is BOMs or bill of materials. So having to know, since there are different types of technologies that underpin the PV modules, having a recycling entity understand what is in the particular modules that they're receiving, and that transparency is kind of a necessary precursor as we try to grow that recycling capability at larger scale than we have currently.
And I believe in Europe, every panel has to be barcoded.
Correct.
Yeah.
In today's costs, without considering salvage values, What have you found the cost to be for recycling a typical 400,000 panel, 1 megawatt solar energy farm?
Costs that I've seen published, I'll just jump in, and this is based on anecdotal information, but it's, I think, the only published value that I've seen is in the range of $20 to $30 per module, and that's for a delivered cost. So that is delivered to the recycler, and that's the cost you would pay the recycler to recycle that individual module. Then, of course, on top of that, you have to pay for the transportation to the recycler, and any logistics and manifesting, et cetera, associated with that.
Okay, the next question is homeowner end user here. Practically speaking, how would I determine if my panel contains hazardous waste? Of course, hazardous regulations vary across nation.
I would say that the tests, that results that we've seen are inconclusive, and that's why ASTM is developing a standard methodology. Panels are not an easy material to sample and analyze according to the EPA tests. What we do know is that they contain materials of concern, whether technically hazardous or not. So one concern is the cadmium telluride panel, which are not often installed for homeowners. They tend to be more industrial, commercial scale, or solar garden, community solar garden type installations. So the various silicon panels that are typically installed to homeowner residents, that we don't have good results, and we would, at Minnesota, we would simply, at this point, encourage recycling back through the vendor, or we do in Minnesota have 2 panel recycling options, or 2 or 3 panel recycling options.
So 90% of PV material is glass. How easy or difficult is separation of glass from the rest of the material?
That's one of the challenges to economic PV recycling, is the separation of the materials. And it's really by design, because PV modules have enjoyed higher and higher reliability over time, and greater or reduced financing because of that reliability. So what we call bankability for solar has improved, because the modules are known to be able to be installed and operated in almost any global environmental condition. So whether it's hot and humid climates, or dry or cold or windy, or etc., this sandwich of layers of materials facing the sun has been able to withstand all of that for a warranted lifetime of 25 to 30 years. And, you know, that's pretty extraordinary. But conversely, that makes a module hard to break apart and separate those materials. And getting the glass separated from the backsheet, or if now with double glass modules, from, you know, a layer in between and then a second layer of glass, getting all that separated out to liberate those materials individually is really one of the fundamental challenges, especially at a cost and a cost target, hopefully eventually, of neutral, meaning the value of recovered materials can pay for the cost of recycling. But that's a long-term R&D target.
Yeah. Do you have time for one more question? I see another one that might pertain to you.
I'll try. Okay.
Okay. This one asks, what are the new PV technologies which are being developed right now with ease of recycling in mind?
There are basically none that are being developed with ease of recycling in mind. I would say that for solar, again, because they've been recycling for so long and have had to manage cadmium, they have their recycling business unit, because they operate their own recycling systems. They have their recycling business unit sign off on any new module design. That, I think, is a best practice when you have you could say vertically integrated, you know, a company that does both the manufacturing and also the end of life management for the same module, that's something that you can then include in that system. That process of designing new modules has to go through the recycling unit to say, is this affecting the recycling? Anyway, but there's really nothing else out there that's been commercially successful and is advancing that I'm aware of in terms of greater recyclability.